Okay, so we go over the parabola, which is one of the conic sections, and in this video we focus our attention on the equations of the parabola when the vertex is at the origin. Okay, so talking about the vertex being at the origin is basically when the coordinates are 0, comma 0, which is this point right here. Right, that is what it means when the vertex is at the origin. All right, so some of the things that we have to understand about the parabola, even just from the definition point of view, is that the parabola is just a set of all points, okay? All points, and we're talking about all points. In this case, we indicate them as x, comma y. It's a set of all points which are x, comma y that are equidistant from a fixed line that is called the directrix, okay? Directrix, something like this. It's a fixed line that is called the directrix, and a fixed point that is called the focus. So a set of all points that are equidistant between this line, which is called the directrix, as well as a fixed point, which is called the focus. When we have those points and we connect them, okay, what we are going to have is the parabola. All right. So what we are going to do here is we are going to we are going to put up a point somewhere. Okay, we're going to put up a point right here. Okay, we're going to put up a point right here, and we're going to name this as our focus, and that is basically F. All right. So we are yet to understand or to know the coordinates of the focus, because we know the coordinates for the vertex, which are 0, comma 0. All right, because it's starting from the origin. All right, and we have to understand that the vertex it can start from any point, or it can be at any point. It doesn't necessarily have to be like always on the origin. No, it's just that in this video we are focusing on when the vertex is at the origin. All right. So another point that we really have to understand is that the vertex is the midpoint between the focus and the fixed line, which is called the directrix itself. Okay, so this point here, all right, this point here, which is the directrix, is the midpoint between the vertex and it's the midpoint between the focus and the directrix. So it basically means the directrix would be somewhere here. All right, it would be somewhere there. So it basically means we have a line that is something like that. Okay, so have that point there. So I'll try to name this line as D to make my work much easier. Okay, uh, that's my D, meaning for directrix. All right. So before we even start to or rather start to put up points to help us understand how we come up with the the parabola using the statement that we have been given, that is the parabola is just a set of all points that are equidistant from the fixed point that is called the focus and the fixed line that is called the directrix. We also have to understand that the angle between the axis and the plane is equal to the vertex angle. So this line that we have right here, this line is the axis. Okay, this line is the axis, and we have our vertex here. We have our vertex right here. Then what we have here, this is the vertex angle. Okay, this is a vertex angle. That's our vertex angle, like that. Okay, so the angle that we are talking about that is equal to the vertex angle is this angle here, because this is our axis and this is the plane. The plane, I've drawn it in blue. This is our plane right here. So the angle between this plane and the axis is equal to the vertex angle, and that's one of the points that we really have to keep dear to ourselves, because it will help us to differentiate when we are talking about whether it's an ellipse, it's a parabola, it's a hyperbola, it's a circle or something. It would be very easy for us to differentiate, because we're able to understand them just from talking about the angles. All right. So, getting back to the parabola itself, we are told is a set of all points that are equidistant between the fixed line, which is in this case we have named as D, and the fixed point, which is called F, which is the focus. Okay, so what it means being equidistant is that you can put up a point anywhere on the line D. So I'll put up a point here. I'll name it as my m. Okay. um, or the same here, I also name it as my m. So any point that is on the line D, you can name it as m. So it's more like there's a line here. Okay, there's a line from m to f, like that. So if you really want to make a sketch for yourselves to get a clear understanding of what this is all about, like how to sketch a parabola on your own, all right, you don't even necessarily have to have some maybe precise measurements or something, because at this point the line mf, you just open your compass to more than half of this line. Okay, more than half of that line, then you pin your compass at m, you make an arc, and I believe it to be somewhere here. Then you pin your compass again at f, then you make an arc, you find that they will cross like that. So you're going to find that at the end of the day, what you're going to have are these points, something like this. uh, Something like that, something like that, something like that. Then we have to connect these points. Of course, my points may not be as accurate as they are supposed to be, but if you try to use a compass, you find that what you're going to do is really going to make sense a lot. Okay, so connecting those points, we are going to have something like, of course, it's going to pass through the vertex, because it's going to be something like that, going up. It's opening upwards, and we are yet to understand how we are able to know from the equation to say, is it opening upwards or downwards, is it opening to the right or to the left. Okay, we're yet to understand that. So it's more like that's the way it's going to be, and we are going to have points like that. Remember, this is going to be more accurate, as I said. If you try to do it with your own compass, you try to do it yourself. Okay, so there we have it. So those points, okay, those points, I'm going to name them as p. Okay, it could be any other letter, but we are more familiar with p. Okay, that is our p there. So all those points are p. So we know to say the coordinates now for p is just x comma what, x comma y. So these are the set of all points that I was talking about from the definition. Okay, so for us to come up with the equation that we are looking for, we also have to understand that when, let's say, when you had to put up a point which is m here, the distance between m, okay, m to p and p to f is the same. Okay, and that's the same if you put a point here again, the distance between this point here and this p going to f, they are one and the same. Okay, so what we are able to derive from this is that the distance fp is equals to the distance pm. Okay, pm, like that. And this is something that is really going to help us to come up with the equation that we are looking for. But before that, we really need to know the coordinates for f, the coordinates for p, and the coordinates for m as well. Okay, so the coordinates for f in this case is 0 comma what, 0 comma p. Okay, like that. This is a point p, and this line here that we have is what, is 0 in terms of the x-axis. That's where those coordinates are coming from. Then uh, for p we know to say this is x comma what, x comma y. Then for m, this is going to be x comma negative p, x comma negative p, like that. Okay, so someone might wonder to say, why is it that the coordinates at m here, it's x comma negative p? It's because this line that we have here, this is the zero line in terms of the y-axis. So any point that is below here is what, is a negative point. It's going to be a negative value. That's why our p is going to be what, is going to be a negative. All right, so this is the information that we need for us to come up with what, the equation that we need, which is the equation of the parabola when the origin is at when the vertex is at the origin. Okay, so we have for p there, and for m we said For m we said it's x comma negative p, like that. Then for f it's 0 comma p, like that. So that's basically what we need. And it's also very important that we remember the formula for the distance formula. Okay, the formula that we use for finding distance between two coordinates. Okay, so you finding the distance between two coordinates is basically the square root of open bracket x2 minus x1 cross bracket squared plus open bracket y2 minus y1 cross bracket squared, like that. So here it could be x1 minus x2, then you raise it to power 2. It's still going to it's still going to be one and the same thing. You might get a negative value, but when you square it, it's going to be a positive value. So this is a formula that we are going to use to find what the equation of the parabola when the vertex is at the origin. So here we need to find the distance of that and the distance of that. Okay, so we are basically going to say the square root of, okay, uh, the square root of fp, I mean the distance fp is equals to also the square root of distance pm, like that. Okay, so here the point fp, we have our f here and we have our p here. So we're basically saying this point minus that point there, and we'll say this point minus that point there. So it's basically 0 minus x as well as p minus y. Okay, so you say open bracket 0 minus x, then you put squared plus open bracket p minus y, you put squared there. We open this side as well. Then for p and m, so we're going to say x minus x squared, like that, plus open bracket we're going to say y of p minus p of m, which is just going to be a positive p, okay, squared, like that. So at this stage you have to square both sides to get rid of the square roots. So that will go and that will go, this will go and that is going to go. So what you're going to remain with is 0 minus x squared plus, this is p minus y squared is equals to, this is our x minus x squared plus y plus p squared, like that. So 0 minus x, this is going to give us minus x, so we square it, that would be x squared plus. So expanding what we have here, what you're going to have is p squared plus y squared minus 2py is equals to, okay, what we have on the other side. So now x minus x is 0, so you just have to expand this part, and what we're going to get is a y squared plus a p squared plus a 2py. So when we reach this stage, we realize there are some variables that we're able to cancel out. The p squared goes and the p squared goes on the other side, the y squared goes and the y squared goes on the other side as well. All right, so what you're going to remain with is x squared minus 2py is equals to 2py. We correct the like terms. This is going to be x squared is equals to 2py plus 2py. Okay, that's what we have right there. Okay, so what you're going to end up having at the end is our x squared is equals to 4py. So this is the general formula for the equation of the parabola when the vertex is at the origin. But this is not the only formula. What do I say so? When you're talking about symmetry, okay, because even just when, okay, let's say uh, we have this as our x-axis and this as our y-axis. Okay, this is our y-axis, like that. So when the parabola is like this, okay, it's open upwards, it might be this equation. or let me say it is that equation that we are using. And all the same, when the parabola is opening downwards like this, it's still this equation. It's just a matter of, is our p positive or negative? That is one of the points that you really have to understand. It's very, 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 very important. All right. So when the parabola is opening upwards, is this equation that we are using. When the equation is opening downwards, is still what? Is still the same equation. And opening upwards or downwards is just a matter of, is the value of p negative or what, or positive. All right. So we are going to use the same. We are going to use the same concept to help us understand the other equation when it's either opening on the right or on the left. So the first equation that we have is, we say it is x squared is equals to 4py. Okay, so maybe before I even go to the other equation, when we are talking about symmetry, okay, when we're talking about symmetry, this equation, we're able to understand that this equation is, when we replace where there is x here replaced with minus x, the equation is going to remain unchanged, because what you're going to have is open bracket x minus x squared like that is equals to 4py, meaning the equation will remain unchanged. What you're going to have is x squared is equals to what, 4py. And when you replace with that, when you replace x with minus x to check whether the equation is going to be changed or not changed, what you're going to have is the same, giving us a conclusion to say, this equation that we have, or the parabola that we are going to have, is going to be symmetric about the y-axis. Okay, which makes sense, because what we have is, that's our x-axis, that's our y-axis, and we have our parabola like this. This is symmetric about the what, the y-axis. Okay, and we know to say we are going to have something like this. Okay, there are times when the parabola is what, is like that, and the times when the parabola is what, is also like that. So the equation when the parabola is like that is what, is y squared is equals to 4px, and that is our second equation. So the same steps that we use to derive this equation are the same steps so that we can use to do what, to derive this equation as well. The only thing that changes is that here, okay, at this point, this is where our focus is. Remember to say, when we had our focus here, the coordinates were 0 comma p, but in this case this is going to be what, p comma what, p comma 0, which is going to change everything, and this is the equation that we are going to have at the end of the day. All right, which marks as our what, as our second equation. Okay, and even if you replace where there is y, we put minus y, the equation is going to remain unchanged, which gives us a conclusion that that parabola that we have is symmetric about the x-axis. Okay, so we're also able to differentiate them from the symmetry point of view. Okay, so this is the equation that we have as our second equation. We say this is y squared is equals to what, 4px. So as I said, whether the equation, in terms of the first equation, okay, in terms of the first equation, whether the parabola is opening upwards or downwards, it depends on the what, on the value of p. Is it negative, is it positive? Okay, it's not about how small it is or how big it is, about whether is it positive or negative. All the same goes for the second equation. Okay, this second equation, whether or not the parabola opens to the right or to the left, it just depends on what, on p. Is it negative or positive? Once again, it's not about how big it is or how small it is. Okay, so another point that I really want to bring to your attention is when is something that you have to know to understand this better. So in terms of the first equation, okay, our x squared is equals to 4py. So in terms of opening upwards or downwards, you can just simply note it this way. When our p is greater than 0, what do we have? And when our p is less than 0, what do we have? Okay, so when our p is greater than 0, it opens what? Opens upwards. opens upwards. When our p is less than 0, it opens downwards. So even just by looking at the value of p before even do the sketching, you're able to understand to say, oh, okay, what I have here opens upwards, or what I have here opens downwards. So looking at the second equation, which is y squared is equals to 4px. So even here, when our p is greater than 0, what do we have? When our p is less than 0, what do we have? Okay, so when our p is greater than 0, um, it opens to the right. Okay, opens to the right, opens to the right. The right meaning it's more like this. Okay, starting from the origin. Then when it's our p is less than 0, meaning it's negative, it opens to the left. Okay, so those are some of the points that you really have to understand about the parabola, and it will be very easy for us to know, I mean, like, what do we get when we sketch? Is it opening upwards? Is it opening downwards? Is it opening to the right? Is it opening to the left? Okay, so that's all in this video, and thank you very much for watching.